Hello students, welcome to my YouTube channel Learn with Ali. So today we will learn the MATLAB code of PCM, that is pulse code modulation. So before discussing the MATLAB code, let first discuss about the basics of the PCM. So pulse code modulation is basically it is not a modulation, it is a analog to binary conversion technique in which mainly there is three block. When let MT is a message signal, which is let sinusoidal signal. When MT is to convert in the PCM, that is binary bits, the first block is sampler, or we can say sampling. After sampling, the samples is quantized. So the second block is quantizer. After quantizer, some quantized value obtained, and that quantized value is converted into binary bits. So for the binary conversion, it is used encoder. Then finally its binary bits obtained, right? So after sampling, here this is the sampled signal. Then for the quantizer, after quantizer, this is quantized signal, and this is the binary bits. So for the sampling process with the MATLAB, I have already making a video for the sampling and reconstruction. So I will not go into deep for the sampling. And for the quantization, let's discuss some basics about quantization. The same technique I have used in the MATLAB. So let a sinusoidal signal, which is given after sampling, this is the MT. Using PCM, this signal has to be quantized, right? So let the peak value, it's let 8 volt, or you can say 8 volt, and similarly it is also 8 volt in the negative. So peak to peak value, or we can say peak to peak, equals to 16 volt. So the second thing, how many bits are required, that is we can say n bit quantizer. So let one quantized value representing 8 bits. So we can say it is 8 bit quantizer. You can change it, for example 16 bit quantizer, 64 bit quantizers. It depends on how the error is, because in quantization you all maybe you know that there is a quantization error of delta by 2. So if delta is reducing, that means the number of labels, we can here we can write L equals to the power n. When n is increasing, that is the number of bits per quantized symbol, so number of labels is increasing, and if the number of labels is increasing, so delta equals to peak, v peak to peak, divide by 2 the power n, that is L. So if L is increasing, that means, sorry, here it is delta is decreasing, and the error, when delta is decreasing, the error is decreasing. So you can say when the number of labels is increasing, the error, quantization error, is decreasing. So in the MATLAB, we have to see that first we will sample the signal, then quantize the signal. For the quantization, we have used, let this is signal, and this is B minimum, and this level is V max. So this is V min, and this is V max. Let, for example, the number of labels is 1 2 3 4 5 6 7 and 8. Let number of labels is 8. If the n is 3, so 2 the power 3 equals to 8, number of labels will be 8. So for that, this gap or this period is called delta, step size. So this is the first label, second label, third label, fourth label, fifth, like this. So what is the quantized value if in the middle of that is actually the quantized value here? If this any value lies between these two labels, so that quantized value is representing by this. Let represent it as Q1 and Q2, and this is V minimum. So I will use this. So first let's go to MATLAB code, then I will show you how this will perform. So for the MATLAB code of PCM, first 3 lines are used: CLC, close all and clear all, which is we are using in every program, and you know what is the meaning of that. Next, for the PCM, first we have to define the n bit PCM, that is how many number of bits is required to for the quantization value, that is one quantization sample. How many number of bits we require to represent one quantized value, so that we have to define. So first, either you can define directly, that is n, if you are representing n number of bits required for the sample value. So you can define directly n equals to 8 or 3 or 16, like that. And similarly, we have to also define the number of samples that we require for every period of the message signal, which is sinusoidal signal. At 2 pi, that is one period, how many number of samples we require, that is actually sampling. So either you can just directly put here value, or you can generalize the program by entering. There is input syntax in the MATLAB which is used to provide the input. For example, when you n equals to input 8, there is then it prompt you to enter the number of bits, that is n bit PCM system n. Similarly, for in samples also we can generalize it as input. So you can run this program for the general cases. For example, when you run the program, it first prompt for entering the n bit PCM, then it's prompt another value, that is enter number of samples in a period. So this is the generalized form. When you fix this run directly. Then the first block I have already discussed about the this PCM is sampling operation. So sampling in process, I have already made a video in which I have done a detailed analysis of sampling and reconstruction also. So I am not going too deep into the sampling. So this is basically generating a sinusoidal signal and plotting that for the original, and we have plot the stem of that sinusoidal signal to get the sample looking like signals. Third, the second block is quantization. This block I will explain. So for the quantization, the first of all we have to define the number of labels required for the quantization process, and the number of label is required is represented by L. It is already I have explained you in the theory that n we have defined n, so to the power n we have defined n, so number of labels equals to the power n. So Bmax equals to, I have already given that Bmax I have taken there in the theory, it is 8, so Bmin equals to minus Bmax. Similarly, the step size, which is delta, that can be defined peak to peak voltage divided by number of labels. So peak to peak voltage we can write as a Vmax minus Vmin divided by the number of labels. So to quantize, we are going to use the quantize, that is quantize syntax, which is inbuilt syntax in the MATLAB. For that you have to first define some partition and some code. So what is the partition? I will explain here. So partition is actually, it is the definition. It is the definition of labels. That means how many numbers of label, how many labels are there, and how to define it. Second, the code is actually quantized value. How many quantized value is there and how to define that. So it's text, and this takes the partition and code and is quantize the value, and we are plotted the quantized value. So let's again go to the just one. So we can see here, this is the number of label. For example, this first label. So first label, if I want to write here, first label equals to Vmin itself. That is why I am not defining the first label in the MATLAB program. The second label can be defined as Vmin plus delta. Similarly, the third label can be defined as second label plus delta, or you can say that is first label, that is Vmin plus 2 delta. Fourth one is Vmin plus 3 delta, like that. So you can define the first label, second label for the partition part. Similarly, for the quantization value, here this is the first quantized value. You can write Q1 equals to Vmin, V minimum plus delta by 2, right? Here second quantized value, if you add in this first quantized value delta, then you will get second quantized value. Similarly, for third Q3, third quantized value, you have to add this part here plus delta, that is, or you can say V minimum plus delta by 2 plus 2 delta. So that is why we are there is a step size of, we are starting from the V minimum plus delta by 2, and step size of delta we are increasing, and the last quantized value, here you can see this is the quantized value. This can be given as V max minus delta by 2. Similarly, the last labels is defined by V max minus delta. So this we have used in the MATLAB. So let's again go to the MATLAB. So you can see the partition, which is number of labels, V minimum plus delta, and there is step size of delta, and V max minus delta is the last partition or last label. Similarly, the code, that is quantized value V minimum plus delta by 2 with the step size of delta, and V max minus delta by 2 is the last quantized value. If we provide in this syntax, this quantized required signal of this is signal S, which is to be quantized, and the Q is quantized value. Indices is mainly the at what label or at what label this quantized value is obtained, it is stored in the indices. Then we have plotted that in the stem form to get the quantized. So after quantization, there is a third block which is called encoder process or encoding process. The quantized value, which is we also can obtain with the indices, it can be converted into it is in the form of decimal, so we can convert it decimal to binary. So we are representing a next figure, we are second figure, in which the code 1, which is quantized value, it is converted decimal to binary. From decimal to binary in the MATLAB, the default syntax for decimal to binary is the lowest, that is left MSB, the right one is, that is from left to right one is MSB, but in the nomenclature, for example, the most significant bit is actually in the left, that is why we have to define that left bit is MSB. So after that we have just converted from parallel to serial, because when decimal to binary is converted take place, every quantized value is taken into 8 bits, and that is in parallel form, 8 cross. Here you can see that 8 cross 61 form you get, but when we have to transmit the signal, we cannot send parallelly, so we have to convert in the to show the encoded binary bits, we have to convert it in the serial one. So that's why we have used this serial converter, that is parallel to serial converter, in the logic form as from I equals to 1 to L1 and for j equals to 1 to n, where n is I have defined at 8. So for every 8 value it is write the same thing, and then again k equals to k plus 1, that is at the 9th place, it again goes to the second decimal value from where it is started. So basically this for loop converts the parallel to serial form, and that is actually the encoded, or we can say the binary bits. So this is the PCM. Then again we can demodulate the PCM, or we can get the original signal from the modulated, that is the PCM signal. So we can also see here, that is For that, it is in the obtained value is in the quantized value is or we can say encoder value is in the serial form. So again, to demodulate the signal, we have to convert it in the parallel form. So for that, we have to use a reshape syntax in the MATLAB. Reshape it in the reshape, it's reshape any matrix which is given by here in the size given by first, that is row cross column, row by column. This is the size of reshape, and which matrix that we have to convert, it is this matrix. So actually we have divide the length of code, that is 488 divided by 8, that is, and we have uses that 8 into here the main funda is here to convert the serial from serial to parallel converter. Then after parallel converting, there we want to find the index corresponding to that, again that is binary to decimal conversion, that is this we get binary, again binary to decimal conversion. From this point we have converted from decimal to binary, now we are converting from binary to decimal. And if the quantized, if the index is given, then we can find the quantized value from the, if the index is given. How we can find the quantized value? Let's see. So if the quantized value is given, for example, if the index is given, for example, this one is 0th level, this is the 0th index, right? So we can see that 0 in we can write V minimum plus delta by 2. This is the first quantized value, and this is we can get this, and plus index into delta. This is the quantized value Q. So V minimum plus delta by 2, this is the first quantized value. If the first index is let 0, so this total becomes 0, and this is the first quantized value. If the index is 1, then we can get that from 1 into delta, that is delta V minimum plus, this is the first quantized value. So this is Q plus or Q1 plus delta. This is the second quantized value. So if the index is, main purpose is here, our main purpose is, if the index is given, we can find the quantized value, and if we can find the quantized value, we can get the original signal, that is actually the original quantized value. So let's again go to the MATLAB code. So here you can see similar thing, V minimum plus delta by 2, it is the first quantized value, and delta into index. If the index is 0, this is the first, if the index is 1, this is the second, third, fourth, we can get the quantized value reverse back. Again we have plotted the Q for the our demodulated signal. So let's run this program. So here you can see enter n value for the n bit PCM. You can write it as 8-bit PCM if you want to generate 8-bit PCM. Then the second thing is enter the number of samples in a period. Here we are putting it as a 30 let. You can put any value. This is the generalized program. So again press enter, then this program is running here, and it will give you the result. So this is somewhat slow, that's why. The analog signal, which is message signal, I already explained about this. This is the message signal, this is the quantized signal. After this is the sampled signal, and this is the quantized signal. After quantization, we have converted the parallel to serial, and this is the encoded signal. Here you see there is 0. So first bit is 0, second bit is 1, third bit is 1, fourth bit is 1. So like that you can also see that where it is coded. You can see this is the binary bits. First one is 0 1 1 1 1 1 1 and then 0 0 1 1, like that it is coded value, binary coded value. Then we can see that this is the demodulated signal. After the encoded, we have decoded the signal, we have got the quantized value, and we have plotted the demodulated signal here. So by this way you can this is the program for the PCM modulation as well as the demodulation process. And if you want to fix the number of here you want to, if you want to don't want to generalize the program, so just uncomment this here, and it is similar pattern, that is n equals to 8, samples equals to 30. When you run this program, it will not ask you for any prompt to give the, it is directly taken n equals to 8 and samples, that is number of samples per period equals to 30, and you will get the similar result as in the previous one. That is, this is the first one, this is the message sampled, quantized, encoded and demodulated. So this is the PCM encoding and decoding using the MATLAB code. If you have any problem with this code, you can just write a comment in inbox. I will try to resolve it. And if you want some other code, for example some like AM, DSPSC, SSBSC, or some other codes in the MATLAB, so you can also comment for that. I will try to write a code for that. So if you like the video, please subscribe my channel, like the video and share the video. Thank you.